Here we have two different reagents to do hydration of an alkene. So let's see what is the difference in that to be able to predict products when you do problems. So the condition that we have below here is mercuration, demercuration, and it goes through a mercurinium intermediate. And every time, guys, when you have an intermediate like that, this is mercury OHC that's positively charged. Say that you have that. And here you will have just a metal. What we need to remember here is that we form that intermediate and that the attack is at the more substituted carbon. Nucleophile here is water. So that's what determines the regiochemistry of that. If water is attacking at the more substituted carbon, the OH is going to end up here, and the H, these are all hydration reactions. Let me write that down. These are two conditions for hydration reaction. So in that case, the outcome is the Markovnikov alcohols. And as I said, we will have here in the Markovnikov pathway, you will have, say, OH here, OH in this carbon, and here you will have, smudging with my hand. So OH there, H on the other end. I don't draw the H. So that is a product of that. Again, this is the Markovnikov alcohol. Remember that we use this condition, mercuration, demercuration, when we want to prevent rearrangements or cations, which can happen if we only use hydration water under acidic conditions. Markovnikov. Okay, so the other condition is to do the hydration, the anti-Markovnikov reuse selectivity. So, and in that case, important to remember is that not only is anti-Markovnikov, but in the product, H and OH end up on the same side. You remember that in hydration, you're adding H and OH across the double bond. Important here is that the H this time is going to be at the more substituted carbon, so it's going to be here, and the OH at the least substituted, but they are on the same side. So this is a syn addition. This is the opposite. So now drawing the product from that reaction, we are going to do, so you see, we not always draw the H, but I'm going to draw it so that we remember that these two end up on the same side. This is what I want you to remember when you do that. Again, this condition is anti-Markovnikov addition to the double bond, H and OH, and these two to the same side. But you can also have the enantiomer to that. So we're going to write plus En, that's the enantiomer. Okay, so that is, say, in summary, what we need to remember about this two reaction. Markovnikov, and also this goes through a mercurinium intermediate that's similar to the bromonium. And so attack on the more substituted carbon is what determines the Markovnikov regio selectivity of this reaction. We do more reactions in other videos.